Hello friends. Today we will configure IPSec VPN with IKE as main mode. We have the topology. Here you can see we have two different sites, site A, site B, and these two sites are connected with each other via a public network. We will configure IPSec VPN between these two sites by using this public network. Here we have two different networks on each site. Here, as you can see that we have a network 192.168.10.0 and 192.168.20.0 on site A and 192.168.30.0 and 40.0 on site B. All the networks have different VLANs. Here you can see that associated VLAN for this network is VLAN 10, and similarly the associated VLAN for this network is VLAN 20. Similarly, VLAN 30 is associated with this network and VLAN 40 is associated with this network. Here we will configure our VPN between these two interfaces. We have networks, you can see that 1.1.0 is connected with the router ISP1, and similarly both the routers are connected with each other on this network 3.1.1.0, and similarly the ISP router 2 is connected with the router B with a network 2.1.1.0. Here we have the task. First we will ensure the connectivity between in all the users. Then we will configure the ACL on the routers. Suppose we want this network. In this scenario, we will configure this network to be encrypted through public network for this network. Means these two networks, VLAN associated with network with VLAN 10 and VLAN 30, will only be able to communicate with each other via VPN, whereas other networks, say VLAN 20, will be able to connect, will be able to approach VLAN 30 without VPN. Only these two networks will be able to communicate via public network over the VPN. Similarly, the procedure will be done in six different steps. First, we will configure the ACLs on the routers. Then we will create IPsec transform set. Then creating IKE keychain and specify pre-shared key. Here we will configure IKE keychain and we will specify the pre-shared key, which will be same on both the routers. Then we will configure IKE profile, and we will create IKE based IPsec policy. Then this policy will be applied on these interfaces. Here you can see the interfaces as well. Interface of first interface of which is connected with user 1, second interface is connected with user 2. Similarly, the interface 48 is connected with router's interface 0/0, and the first interface 0/1 of both the router is connected with each other. And similarly, these two routers are connected with each other via 0/0. Similarly, these two routers are connected with each other via 0/1. Similarly, G 0/0 is connected with the 48 port of the switch. First port is connected with user 3 and second port is connected with user 4. Let's remove the site IDs in order to more elaborate the interfaces of these devices. First, we will configure our topology to ensure the connectivity of all the end users with each other. So guys, let's start our configuration with our switch A. System view, host name, switch A. We will configure two VLANs, VLAN 10 and 20 on this switch. VLAN 10 and VLAN 20. Now we will configure interface 1 for VLAN 10 and interface 2 for VLAN 20, and we will configure our interface 48 interface as a trunk link. Interface gigabit 1 slash 1 port link type access port access VLAN 10. Interface gigabit 1 slash 0 slash 2 port link type access port access VLAN 20. Interface gigabit 1 slash 0 slash 48 port link type trunk port trunk permit VLAN 10 and 20. Save. Configuration of this switch A is completed. We will configure our router. System view, host name, router A, interface 0 slash 0, which is connected with the trunk link of this switch. Interface gigabit 0 slash 0. Now we will configure the sub interfaces on this interface, as we have two VLANs which are going to be terminated on G0 slash 0. Interface gigabit 0 slash 0 dot 10 VLAN type dot 1Q VID 10, and we will give the IP address 192.168.10.1 with subnet mask as 24. Interface gigabit 0 slash 0 dot 20 VLAN type dot 1Q VID 20, IP address 192.168.20.124. Interface gigabit 0 slash 1, which is connected with the router of ISP, and we will assign the first IP of this network to this interface G0 slash 1. IP address 1.1.1.1. Now we will configure OSPF 1 area 0 network 192.168.10.0 network 192.168.20.0 network 1.1.1.0. Configuration of this router is also completed here. Save. We will configure VPN on this router later. First, we will ensure the connectivity of all the devices. We will configure our router of ISP. System view, host name, router ISP1 interface gigabit 0/1. IP address is second IP address of the network. Interface gigabit 0/0, which is connected with the router of other with the second router of the ISP. IP address is this network, first IP address of this network, 3.1.1.1, and quit. Now we will configure OSPF 1 area 0 network 3.1.1.0 network 1 dot synced with the neighboring device. Save configuration. We will configure our second router of the ISP. G0/1 is connected with the router of site B via network 2.1.1.0, and G0/0 is connected with the second with the first router of the ISP. Guys, let's start. System view, host name, router ISP2, interface gigabit 0/0, IP address is 3.1.1.2, and interface gigabit 0/1, which is connected with the router of site B, and IP address will be 2.1.1.2. Now we will configure OSPF 1 area 0 network 2.1.1.0 network 3.1.1.0. Neighboring device, which is this router, has been synced. Now we will configure our this switch, and then we will configure our the router of site B. Here we have two VLANs, VLAN 30 and 40. System view, host name is switch B, VLAN 30 and VLAN 40. Sorry. Two VLANs, VLAN 30 and 40. Okay, now we will assign these VLANs to their respective interfaces. Interface gigabit 1/0/1, port link type access, port access VLAN 30. Interface gigabit 1/0/2 port link type as port access VLAN OT. Save configuration. Now we will configure our this router of site B. System view, host name, router B, interface gigabit 0/0/30 VLAN type dot 1Q VID 30 IP address 192.168.30.1 interface gigabit 0/0.40 VLAN type dot 1Q VID 40 IP address is 192.168.1.24. Now configuration is almost complete. OSPF1 area 0 network 192.168.30.0 network 192.168.40.0. Oops, one area is missing here. OSPF1 area 0 network 2.1.1.0 interface gigabit 0/1 IP address 2.1.1.1.24. Now let us check the accessibility of our end users. First we will assign the IP addresses to our end users. Enable IP address 192.168.10.50 255.255.255.0 192.168.10.1. Enable 192.168.20.50 255.255 192.168.20.1. Enable 192.168.30.50 255.255.255.0 192.168.30.1. 192.168.40.50 255.255 40.1. Done. Let us check. Ping 192.168.30.50. It is not accessible. Let me check the second. It is also not accessible. Let us troubleshoot it. Ping 192.168.10.1. Ping 192.168.30.1 is accessible, so why it is not accessible? I think I didn't configure the 48 port as trunk port. Interface gigabit 1/0/48 port link type trunk port trunk permit VLAN 10 and 20. Sorry, 30 and 40. Now let us check. Accessible. Now let's start our configuration of VPN, IPSec VPN. This VPN will be configured between these two interfaces. So guys, let's start. System view first, we will configure our ACL. ACL number 3000 rule permit p source 192.168.10.0. This network with wildcard mask as 255 and destination will be this network 192.168.30.0 with wildcard mask. ACL has been configured. Now we will configure our IPSec transform set. IPSec transform set as test 1 and our encapsulation mode will be tunnel. We have two options, transport mode and tunnel mode. We will select tunnel mode here. Then we have protocol as ESP, encapsulation security payload, which provides the confidentiality and authentication of the data. Now we will configure the encryption and authentication algorithms. ESP encryption algorithm as AES PC192 and ESP authentication algorithm as SHA-1. Now we will configure our IKE keychain. IKE keychain, and here we have to give a name. We give a name keychain 1 with capital K. Now we will specify the pre-shared key here for the remote address. Here for this router, our remote address will be this interface IP address, which is 2.1.1.1. Pre-shared key address 2.1.1.1 and subnet mask is this with key simple and key root, which should be same on both the routers. Root at the rate 12345. This, keep in mind, this key should be same on both the routers. Now we will configure the IKE profile. IKE profile with name prof1. Here we will specify the keychain 1 and match remote identity address, IP address of the remote end. Now we will configure the IPSec policy. IPSec policy name as policy 1 and number as 10, and here we have the options ISAC MP and manual. We will use ISAC MP IKE ISAC MP. Here we will mention the remote address, security ACL number, transform set we created earlier, and the IKE profile which we configured earlier. Remote address will be 2.1.1.1 and security ACL number is 3000. Transform set is test 1. Think I configured the test 1. Yes, test 1. And here we have IKE profile, IKE profile prof1. I think profiles keychain, yes, prof1. Now we will map this policy on the interface, which is the 0/1 interface of this router. Interface gigabit 0/1 IPSec apply policy 1. This is done on our router A. Save configuration. Now we will configure with the same procedure our router B, which is this router. First we will configure our ACL. I'll do fast this I'll do very fast this configuration. I hope you have understood the configuration of our router A. System view ACL list number 3000 rule permit IP source. Here we will configure the IP source. This is will be the IP source here, and destination will be this IP. IP source 192.168.30.0, destination 192.168.10.0. Quit. And now we will configure our IPSec transform set. IPSec transform set as test 1. Now we will configure the encapsulation mode as tunnel and protocol as ESP. Encryption algorithm will be ESCPC 192 and ESP authentication algorithm will be SHA-1. Now IKE keychain key chain 1. Here we will specify the pre-shared key which we configured in our router A as well. Pre-shared key address, which will be the address of our router A's interface. 1.1.1.1 255.255.255.0 and key simple root @12345. IKE profile prof1 keychain key chain 1 and match remote identity address, which is 1.1.1.1 255.255.255.0. IPSec policy 2 number 10 is a campy remote address 1.1.1. Security ACL we created with number 3000. Transform set as test 1 and IKE profile as prof1. We will map this policy on our outgoing interface, which is the 0/1 of this router G0/1. Interface gigabit 0/1 and IPSec apply policy 2. Our configuration on both the router has been completed. All the task has been performed. Now we will check. First we will capture this interface via Wireshark. Now we will observe. First let me check. IKE display IKE ESA. Nothing. When we will ping our respective end users, then we will be able to see the entries in this table. Let's ping. Let me show you another thing here. Display IPSec SA. Nothing. Display IPSec statistics here. 0. Ping 192.168.30.50. Here you can see ping has been received. In this you can see received and sent 4 packets. Entries have been and display IKESA. You can see local IP address is this, remote is this, and let me show you in Wireshark as well. Here, this is the process of creation of IPSec VPN. This is next. You can see that ping encapsulating security payload. Similarly, if we will ping from this user to the user of VLAN 40, then what will be the response of Wireshark? Ping 192.168.40.50. Here you can see 10.50 is pinging 192.168.40.50, and this is the simple IPSec ping IPSec packet and response, reply, request. There is no encryption in it. This is the simple internet control message protocol. So friend, this is how you can configure IPSec VPN by using IKE as main mode. If you have any query regarding this lab, you can and feel free to ask me in comments. Thank you.